Hello everyone, in this video we are doing the 2022 November ECZ question paper and the question is under more concept. Like if you are ready, subscribe for more videos like this. Let's dive in. So calcium nitrate decomposes on heating according to this equation here, according to the equation given here. So it decomposes to form calcium oxide, nitrogen dioxide and oxygen gas. The question reads, copy the equation given and balance it. Calculate the relative formula mass of calcium nitrate. 16.4 grams of calcium nitrate is decomposed. Calculate the volume of oxygen gas liberated at room temperature and pressure. So let's start by solving the first equation given, which is copy the equation given and balance it. So how do we balance the equation? So we're going to ask ourselves, what elements in this equation are not the same? The number of elements are not the same on either side of the equation. So in this case, if we look at calcium here is just one element here. As well here on this other side of the equation is just one. Now nitrogen here is 2 because of this 2 here. So nitrogen is 2 here. Nitrogen here is 1. Oxygen gas here is 6, because 3 multiplied by 2 will give you 6. Oxygen gas is 5 here. If you add 1 plus 2 will give you 3, plus this one here will give you 5. So it's 5. So once you have identified the individual elements, you can now look at any of the elements that are different. Any of the elements that don't have the same number of elements. So like oxygen, what I mean is oxygen here has 6 and here it has 5. So how can I make oxygen gas here be 6, just like this side? How can I do that to make it become 6 this side? So if I put a 2 here, oxygen gas would be 6. So here it would be 2, oxygen gas will be 2 here, plus this 2 here, plus this 2 there, that will give you 6. Now this 2 not only affects oxygen, but it also affects calcium. So calcium becomes 2, but here calcium is only 1. So if I want to make calcium 2 as well here, I'll put a 2. So not this 2 not only affects calcium, but it also affects nitrogen and oxygen gas. So nitrogen will change from being 2, but it will become 4, because this 2 will multiply with this 2 to form, and the answer you're going to get is 4. So nitrogen will become 4 instead of 2, because the 2 affects everything. So if nitrogen here is 4, but here it's 1, so I have to make it 4 here as well by putting a 4 there. So this 2 that we put here not only affected nitrogen, but it also affected oxygen here. So oxygen gas changed from being 6 to 12, because this 3 will multiply with this 2 here to form 6, then to multiply with the 2 here outside, then 6 multiplied by 2 will give you 12. So oxygen gas has changed from 6 to 12. Now let's check the other side of the equation, the number of oxygen elements that we have. So here it is 2, then this 4 multiplied by this 2 to give you 8. So we have 8 oxygen elements, plus this 2 here will give you, plus these ones here will give you 10, then plus this give you 12. So it has balanced. So then you have balanced the equation. Now the next question is calculate the relative formula mass of calcium nitrate. So the first thing you need to do if you want to write the relative formula mass of calcium nitrate is to write the chemical formula of calcium nitrate, which is this one here, which is this one there, without the coefficient 2 there. So this is the chemical formula of calcium nitrate. Once you write the chemical formula of calcium nitrate, you can write the relative formula mass of calcium nitrate. So this is the chemical formula of calcium nitrate. Now let's find the relative formula mass of calcium nitrate. So the first thing you're going to do is ask yourself, we're going to identify the individual elements. We have calcium, nitrogen, and oxygen gas. So we're going to start with calcium. So we're going to ask yourself, how many elements are there for calcium? There's only one. What's the mass number of calcium? It is 40. So I say 40 multiplied by the number of elements, which is 1, will give you 40. Then we're going to move on to nitrogen. Nitrogen, how many elements are there? There are 2 because of these 2 outside here. So nitrogen multiplied by the mass number of nitrogen, which is, so will be 2 multiplied by the mass number of nitrogen, which is 14, to give you 2 multiplied by 14 will give you 28. Then we're going to ask yourself, how many elements of oxygen gas do we have? We have 6 because of these 2 outside. 3 multiplied by 2 give you 6. So 6 multiplied by the mass number of oxygen, which is 16. So 6 multiplied by 16 will give you 96. So that's how you find the relative formula mass. So 40 plus 28 plus 96 will give you 164. So 164 is the relative formula mass of calcium nitrate. So the key is the number of elements multiplied by the mass number. So in this case, we only had 1 element of calcium, so put 1 multiplied by the mass number of calcium. Nitrogen had 2 elements because of these 2 outside, multiplied by the mass number, which is 14. Oxygen, we had 6 oxygen elements. 3 multiplied by 2 will give you 6, multiplied by the mass number of oxygen gas, which will give you 16. So then 40 multiplied by 1 will give you 40, 2 multiplied by 14 will give you 28, 6 multiplied by 16 will give you 96. Then you add, then that's your relative formula mass of calcium nitrate. The alternative term you can use is relative molecular mass. They could use relative molecular mass instead of relative formula mass. It's just the same thing. So then we move on to the next question, which is the last question. 16.4 grams of calcium nitrate is decomposed. Calculate the volume of oxygen gas liberated at room temperature and pressure. So the first, I would love to mention this. Whatever you are given in the question is what you use to find the answer. So in this case, we were given the mass of calcium nitrate. That is what we're going to use to find the volume of oxygen gas. Nothing else. We'll use whatever we've been given in the question. So now, how do we find the volume of oxygen gas? So we're going to ask yourself, which formula can I use to find volume of any gas? It is this one. Number of moles is equal to volume over molar volume. So all I'll just have to do is make V the subject of the formula, which is volume. So volume will be equal to number of moles multiplied by molar volume. So molar volume is the volume of any gas at RTP or STP. RTP is room temperature and pressure, while STP is standard temperature and pressure. The molar volume of any gas at RTP is 24 decimeter cubed, while at STP it is 22.4 decimeter cubed. RTP is room temperature and pressure, STP is standard temperature and pressure. So volume of oxygen gas at RTP, we already know the molar volume because room temperature and pressure, any gas has a molar volume of 24 decimeter cubed. So we already have the molar volume. What we are missing is the number of moles. What's to find the volume? Volume will be equal to number of moles multiplied by molar volume. We already have the molar volume, which is 24 decimeter cubed, but we don't know the number of moles. So our aim will be finding the number of moles so that we can use the formula to find the volume. So now, how do we find the number of moles of oxygen gas? We're going to use the mass of calcium nitrate that was given in the question, which is 16.4 grams of calcium nitrate. So how are we going to find the number of moles of oxygen gas? We're going to use what we call the mole ratio. So if we want to use the mole ratio, we have to find the number of moles of calcium nitrate first. We only have the mass of calcium nitrate, so we have to find the number of moles of calcium nitrate so that we can use the mole ratio. So how do we find the number of moles of calcium nitrate? We use the formula number of moles is equal to mass over molar mass. So the mass here divided by the molar mass. So the mass was given in the question divided by the molar mass, which is 164 grams per mole. Relative formula mass and molar mass are the same, except that molar mass has units grams per mole. While relative formula mass does not have units. relative formula mass has no units, while molar mass has units, grams per mole. That's the only difference. Molar mass and relative formula mass, you find them the same way, except that relative formula mass has no units, while molar mass has units, grams per mole. So mass is 16.4 grams divided by 164 grams per mole. Then you have 0.1 mole. Then we have the number of moles of calcium nitrate, which is 0.1 mole. Now we can use the mole ratio to find the number of moles of oxygen gas. Once we have the number of moles of oxygen gas, we can use the formula to find the volume of oxygen gas, which is what we want. So we're going to get the coefficients in the balanced chemical equation. So what is the coefficient in front of calcium nitrate? We have 2. What about in front of oxygen gas? We have 1. When you don't see if you don't see a number in front of the element, it is 1, that the coefficient is 1. So we're going to say 2 moles of calcium nitrate. We're going to form a ratio. 2 moles of calcium nitrate will give you 1 mole of oxygen gas. I got this from the balanced equation. 2 moles of calcium nitrate will give you 1 mole of oxygen gas. So 2 moles of calcium nitrate will give you 1 mole of oxygen gas. Then you're going to ask yourself, what are the number of moles of calcium nitrate? We found the number of moles of calcium nitrate, which was 0.1 mole. So this 0.1 mole we put here. 0.1 moles of calcium nitrate will be equal to X. You don't know the number of moles of oxygen gas. That's what we're looking for. So then you cross multiply. So 0.1 multiplied by 1 will give you 0.1. X multiplied by 2 will give you 2x. So for us to remain with x alone, divide by 2 everywhere. So 0.1 divided by 2 give you 0.05 moles. So that will be the number of moles of oxygen gas, which is here 0.05 mole of oxygen gas. So this is the number of moles of oxygen gas, 0.05 moles of oxygen gas. Now that we have the number of moles of oxygen gas, we can use the formula to find the volume of oxygen gas at RTP. So volume will be equal to, using this equation, we'll make volume, using this formula here, we'll make volume the subject of the formula. So volume will be equal to number of moles multiplied by molar volume. So the number of moles of oxygen gas is 0.05 multiplied by molar volume, which is 24 decimeter cubed, because every gas has molar volume 24 decimeter cubed at room temperature and pressure. Then the volume will be 1.2 decimeter cubed. That is all for today. See you in the next video.